If we can get everything done, I have a little video for us to watch at the end. That would be fun, but I don't know if we can finish in time, so let's see. Oh. By Heart has some cool ones for sequences and series. Okay, here we go. How'd the calculators go? Any questions? We're okay? Okay. But what else were you supposed to do besides writing down the formulas and trying it in your calculator? You were also supposed to use the formula. Well, what did your calculators say? What do we know that we're supposed to be? As long as we all plugged it in right, we should have the same answer. 5 point? Okay, that's what we think we should be going for. Tyler. Yeah. And it didn't match? Okay. Let's try to figure it out. So how did you plug it in, Tyler? Because she was doing the rest of the problem, which was trying to plug it into this formula. Because this is kind of, to be honest, this is kind of like a parenthesis. Like, it's kind of an aside. It's like a, oh yeah, that's true. But the main point is actually this one. So, okay. What'd you put in the A1 spot, Tyler? Good, I agree. And then 1 minus, what'd you put in the R spot? Good. And what was your N? Careful. There you go. That was the one little baby piece you were missing. So when we plug into the formula, our A1, if it's written, now this is kind of hard because in this sense, or in this example, it was exactly the same. So we're like, oh, sweet, let's go stealing things. We can steal the 4, steal the 0.3, steal the 12. But in other ones, it actually might be written differently. So not every geoseries looks exactly like this. Can I just show you? You don't have to write this down, but can I show you another one? What if I was to show you something like, geoseries or not a geoseries? Does it look exactly like this? How could we know if something is a geoseries or not? Maybe, but how do geoseries look in graphs? Like arithmetic is like, oh, it's going up. Oh, it's going down. Plug in? Oh. Okay, so plug in. What do we plug in first? Now, usually we plug in 1, but why are we plugging in 0 in this one? Oh, remember it can start at 0 or 1. Just for our purposes, we're almost always starting with 1 because it's easier. So if you plug in 0, what's anything to the 0 power? 1. Anything to the 0 power? 1. Anything to the, 0 plus 1 is 4 to the 1. Oh, so the first term is 1/4? Okay, so then how do we do our second term? It's technically a sub 0, which is kind of awkward, but plug in 1. Oh, okay, so now that I have 1, wait a minute, what's negative 1 squared? Oh, it's a positive. Is that ever going to be anything except for a positive? No. Yeah. Plug in 2, it's to the 4th power, still even. Plug in 3, it's the 6th power, still even. Oh, well, that negative 1 doesn't really do anything at all. But if I plug in this guy, 3 to the 1 would be 3, and 4 to the 1 plus 1 would be 16. And if I plug in 2, well, forget him, he doesn't do anything. That'd be 9. And plug in 2 plus 1 is 3, that'd be 64. Is this a geoseries? Yeah, it is. Because what's being multiplied every single time? 3/4, 3/4, 3/4. So could I say, oh, my A1 is 1/4, my R is 3/4. What would my N be if I was plugging into that formula? We need to get that formula down. N is the nth partial sum. It's up to, remember yesterday? The nth partial sum is what do you add up to which term? This one was add up to 12. This one is add up to 12. Why? Ooh, there's an extra term. Do you see it? If I plug in 0 and 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10, there's 12 terms. 1, 0, 1. From 0 to 11, there are 12. Okay, but what was I trying to show you on this page? Was I trying to trick you? No, I was trying to be like, geoseries can show up in other ways. So even though Tyler was like, yeah, there's the A1 and there's the R and then the N, took a little bit of work, but now we realize hopefully it's the upper number whenever we start at 1, or maybe a better way of saying it is it's the number of terms you're adding together. Bless you. Maybe that's a better way of saying it. It's the number of terms we're adding together, which from 1 to 12 is 12, from 0 to 11 is 12. I just want to warn you, geoseries can show up in different ways. But did anybody try plugging in to see what happened? Now hold on, don't tell me the answer. Well, we know the answer. But can anyone do me a big favor? Why would I not have you do this by hand, and why would I have you go to the calculator? To the 12th power? I have to do 3/10 to the 12th power? 3/10 times 3/10 times 3. But can I show you a way of approximating this? I'm going to put a big old approximate. Because I'm not saying it's exactly true, but can we see how close my approximate is? 7 goes into 40 5 times, right? Subtract 35. 40 minus 35 is 5. 7 goes into 5 how many times? Or sorry, 50 how many times? 7. 50 minus 49 is 1. 7 goes into 10 how many times? 1. 10 minus 7 is 3. 7 goes into 30 how many times? 28. And then 28, 30, that's 2. 7 goes into 20 2 times. How close did I get? Does anybody have any more decimals from your original summation one? 286? Kiddos, how close did I get? And I didn't even keep on dividing. Maybe I should have kept dividing. Why did I do this? How did I do this? What did I do? This just came from what? So what did I do? Who didn't I even pay attention to? I didn't ignore him. I made him 0. What? What was 0.3 raised to the 12th power? Why? E. E. It's e to the negative what? So 0.00000. Oh. Can you guys help me out for a second? What else would give a really, really, really small number when raised to the 12th power or the 10th power or the 8th power? 0.8? Sure, try it. What's 0.8 to the 12th power? 0.068? E what? No E. Okay, so it's not as small, but is it still small? But it's not the 0.00000. How about 0.99? What's 0.99 to the 12th? Okay, so it's bigger. Let's try 0.99 to the 100th. What's 0.99 to the 100th? Maybe it just takes longer to get small. Any E's?
No.
No? What's 0.99 to the 1000th? Ooh. So some decimals take longer to get tiny than others, but what are all decimals? As n gets bigger and bigger and bigger and bigger and bigger, what are all decimals going to go down to? Smaller and smaller and smaller to 0. But what if I was to do like 1.01 to the 12th? What'd you get? Okay, how about 1.01 raised to the 1000th? Because you're like, it's almost 1. Like, I don't get it. Whoo! Are you serious? What's 1 to the 1000th? Ha ha! I tricked you while you were starting to type it in. So what's the difference between 0.99 to the thousandth, 1 to the thousandth, and 1.01 to the thousandth? A world of difference. Wasn't 0.99 to the thousandth 0.0000 stuff? 1 to the thousandth is 1, and 1.01 to the thousandth was 20,000 something? What makes the difference? On what side of 1 you are? On what side of 1 you are? Hold on, wait. What about negative numbers? What do you guys think negative 0.3 to the 12th is going to be? It's going to be a positive, but isn't it going to be tiny again? Yes. What do you think negative 0.99 to the thousandth is going to be? A positive, but it's going to be, once again, tiny. Oh, put your negative in parentheses. Because remember, your calculator saves the negative until after the power, unless it's in parentheses. PEMDAS, exactly. Exponent, then multiplication. How about negative 1.01 to the thousandth? It's a positive number. Joe's saying it's a positive because he's like, it's the same as the other because it's a positive. Okay, if we did the 13th power, it would be a negative, but it would still be really, really big, just negative. Or it'd be really, really small, but negative, if it was like the 13th power. So what Joe's saying is, in this one, because I'm having you test the 12th, it doesn't make a difference, or the thousandth, because it's an even, it doesn't make a difference. But if it was an odd, the signs would be different, but it's still the same pattern. What makes this little baby piece of the formula eventually go to 0 if this is ever expanding or if this is getting bigger? What side of 1 it's on, or what side of negative 1 it's on. And so we're going to talk about that. Wait, why are we talking about this? I don't understand. What's the big deal? I could have just put it in my calculator. I know. I could have just put it in my calculator. I know. I didn't have to put it in my calculator. But also, I'm getting you ready for... Wait a minute. What does this say? Finite. Why are they telling me finite? Whatever. Why didn't they just tell me the sum? Because there's infinite coming. Okay. Hold on, but before the infinite, let's practice a little bit more. Find the sum of the finite. So why was I having you go from 12 to 100 to 1,000? I was having you head the direction of infinity. I didn't actually have you go to negative infinity. I had negative numbers going to infinity. But I didn't actually have you head to negative infinity yet. That's in chapter 12. Okay. What? Because remember, with sequences in series, we only go the positive direction. We only go first, second, third, fourth. We never go like, I mean, I guess sequence of events, you could say what happened before, but in math, we just start at 0, start at 1. This is the starting point, and we head one direction in positive infinity's direction. Anyway, does this look exactly like that card? Or that, I say cards because in calculus they have to like write these important things, these yellow boxes on cards and memorize them. Sorry. The yellow box from the page before, does this look exactly like it? Some of you would say yes, some of you would say no. They're actually both right depending on what your brain is thinking. But here's the long story short. What did you guys just see a second ago where I didn't even have to match it to the card? How can we figure out the A1 and the R and the N without even worrying about looking at the little sigma on the yellow box? You could use the 10, yeah, because from 1 to 10, how many terms will there be? 10. So, I mean, I can do that, but I also need A1 and R. What did you see me do? Joe's like, oh, why don't you just... What did he tell me to do that I started doing and we were able to see what it was without comparing it to the yellow box? Who is this guy? I don't know. Yeah, you do. What'd you do in section 9.1? What'd you do in section 9.2 when they told you find the first 5 terms? What'd you do? Plug it in. So plug it in, plug it in. Plug in what first?
1.
What's anything to that 1 minus 1, 0?
1.
Plug in. 2 minus 1 is, oh, it's 3/2. Plug in 3. 3 minus 1 is 2. Oh, that's 9/4. Do you guys see what I'm talking about? Who is this guy? A geoseries. Why is he a geoseries? Because you're multiplying by a common ratio of
3/2.
Do you see how I figured it out without having to compare it and make it look exactly like that A1 times R n minus 1? What's my A1?
1.
Or my first term? Now, those of you that are like, no, it looks like the yellow box, you're right. There was an A1, and there was an R, and there was an N. But for others of you, you're like, I didn't see it. There was no number in front. Well, there was. But for others of you, we can always just start writing a few terms and then figure out the stuff ourselves without having to memorize that sigma thing. Now, are we going to have to memorize this guy? Yeah. Yeah. But you have to memorize that. See why he's in parentheses? It's like, we can always plug in, find the first few terms, and go from there. Matthew, you had a question. Sorry, bud. What's up?
So, could you just plug in 10 for amend the first time and get your answer that way? Because the question already tells you that it's a geometric.
True. But remember, if we plug in 10, what we're trying to find is the sum, so S sub 10, not A sub 10. So if we plug in 10, we would get the 10th term, but we wouldn't know what the addition would have done to all the 9 terms before unless we plug into the S sub 10 formula. Does that make sense? Yeah. So guys, what is the S sub 10 formula? Do you remember? I mean, you can look in your notes. I have it memorized. You don't need to, though. How does that formula work? Wait, you can read it out of your notes. Look at your notes. A1. Is that cool if I put in 1?
Yeah.
Parentheses?
1 minus r to the nth power over 1 minus r.
Can I put 3 halves to the
10th power.
10th power all over?
1 minus 2.
Why am I not going to cross him off and put 0 and be like, yeah, it's close enough. It's bigger than 1. So plug in real quick. What's 1.5 to the 10th power? Or 3 halves to the 10th power. It's not going to be getting closer and closer to 0. 7.666? Oh, 57. Am I in a little bit of trouble? Yeah. Elephants. Stop. Okay. Yeah, I'm in a little bit of trouble. Just in the sense of mental math. Now, guys, I wouldn't make you raise 3 halves to the 10th power on a test. But did you hear what Lauren asked me yesterday about why can't we just plug it into the calculator, right? What if this was on a test and I wanted you to show me the S sub n formula, but I was allowing you to use your calculator because the numbers were gross? It'd be a multiple choice, and I would have an S sub 10 with an equals and a blank so that you give me the multiple choice answer. You could have just thrown this in, but you also get points for getting the formula right. Does that make sense? Okay. But when you guys plug in chug, you can plug in the sigma or you can plug in the formula. What do we end up getting? 113.3. Which you could have gotten pretty quick by doing, Not negative? Positive? Yeah, I know. Hold on. Oh. Because I can't subtract. It was 1 minus 3 halves, which would be negative 1 half. And a negative over a negative is a positive. The reason I did that is I was doing mental math. I'm like, oh, it's easy. It's negative 56.665 times 2. And I was like, that's a negative number. But negative 56.655 times negative 2. All right, positive 113.330. Number 72, guys, do you even see a sigma? So the only way you could do a sigma is if you were able to rewrite this and get it into this form. So, or just figure out the pattern and then add them all up. Figure out the pattern. Yeah, because how many terms are in between? Oh. Hold on, what's the pattern? We have our A1 is 32. We have our R is it an R? Remember how we can always divide? If it's geo, shouldn't these be the same thing?
Yeah.
6 goes in 3 times and 4 times. 8 goes in 3 times and 4 times. Sneaky, sneaky, sneak. So if I was to put this into a sigma, okay, fine, I could put it in. I could say n is equal to 1. I could put in my A1 to be 32. I could put in my R to be 3/4. I could put in my n minus 1. Because the first one, I need this to not matter and just be 1. The only way to make it 1 is if this is 0 and he's left. And I can make the power 0 if it's n minus 1. Anyway, I could also pull it out of the yellow box. But how do we know when to stop? Well, I guess we could have done, couldn't we do 18 times 3/4 and see what that is? We could go ahead and we can have 2, and then we could have 9, and that'd be 27 halves, which would be 13 point. Oh, I need to go again, don't I? So 27 halves. And then what if I multiply that one by 3/4? And then that would be 80, 60, 81, 8. Ah, look, that would be 10 point. There he is. So I need 1, 2, 3, 4, 5. Got him, coach. Now, did I use any formulas? No, because I was being too lazy, and I was like, ugh, I don't want to use a formula. But could I have plugged in this as my a sub n, being like, I have a formula, so I'm going to try to figure it out. But what would have been the problem? Oh, is this as easy to get to n as it was in arithmetic sequences? Arithmetic, it was n minus 1 times d. All I had to do was divide and add and subtract. But what's the struggle with where n is now? He's in the power. Guys, how do I get a power down? Like, let's say this was like the 20th term. Are you really going to do this 20 times to figure out where it is? You have to know when to stop it, or else you have no idea how to put it in a sigma. And do you really want to like do the pattern 20 times? Ugh. You can't square root. What should you do first? I mean, this is my problem, but I mean, at least what should you do first? Yeah, divide by 32. So I would do 10.125. Okay, now we can zero in on the problem. And the problem is, I need the n minus 1 down. There's only one mathematical thing that'll do that for me. What's the one mathematical function That is laughing in your voice is totally okay.